Welcome back, generals, to another Let's Fix Generals 0 hour to make the best game ever. And we are back with unassemblize. Last session we did explore the stack string. We added a new library which contains small containers, which appears to be good for what we need. And now we need to think about how we do the formatting on those strings, and I think I have an idea. So this one here has a limitation of the max size, right? But we need a version where we can format without size limitation. So how about we do so okay, so we don't put a max size, yeah, just like that, output. Okay, so, and then we can say if if not output, capacity is, if output capacity is larger than 0, it's not 0, then we do output resize to the capacity, yeah, and then we do format to n output dot begin output dot size format yada yada. Okay, and then we check written. Was it written distance? Then we say if written is smaller, no, yeah, if written is smaller than, no, if result dot size is smaller equal output dot size, then we do written then we do then we put an assert. No, we don't need assert. So if result.size is smaller output size, then we simply output resize result size, right? Because it fits in there. Okay. And then we return here. Return, we're done. Everything good. Otherwise we do well, even if capacity is 0, maybe we don't need this capacity check. So if written, no, if maybe put an else here. It calls output buffer was large enough. Else output buffer was not large enough. Then we do output dot it's also doing resize, isn't it? Bool let's just duplicate this for now. So if it is not large enough, then we also resize it by this size, because we now know it needs this much space. And then we do another. Then we do another format. Do result 2. Right? And then we do assert result 2 dot size equals output dot size, right? And then that's it. I think this would be it. Maybe you can simplify this. We say maybe put here as size t, const size t, size, Or say initial size. Then we do initial size here and put initial size there. Okay, and then we put this one up here. And then we say if result size is larger than initial size, then we just do this. Output buffer was not large enough. Try again. Then we don't need this anymore, and we just do this. Here we can reuse this guy. Just use result again. There we go. Yeah. Yeah, it looks correct to me. Okay, how do we do this one here? Append formats. So that's a sign. Let's do append. Append formats. Okay, so there we would have a string output. So initial size, we also use a capacity, yeah. So initial size, output capacity, resize. Then we need to have a begin here, format and begin, max size, begin max size. So it's append format, begin. So initial size. So output resize, initial size. Yeah, I think this would be correct for starters. And then we need to append to. Oh, we put it here by mistake. Let's move it on here. So start pos. Where's start pos? Huh? Output.size. Right. Output.start pos. Begin. How about, or we also call this initial size. Initial size plus max size. Let's call it initial underscore size for now. Initial size, okay. And here we do also initial size. Okay, so initial size is that, yeah. But hold on. Hold on. Capacity, initial size. But it's actually not quite right. This one is initial size. We should call it initial capacity. Initial capacity. Yeah, let's call it initial capacity. Okay, so then we also need the initial size. Const size t, initial size. Right? Output dot size. Okay, and the initial size is essentially so the begin becomes output dot begin plus initial size, aka begin plus initial size. So begin with initial capacity. And then we resize to initial size plus result dot size, right? And then we check if result dot size is larger than if initial size let's call this const size t new size. New size is this stuff. But if new size, well, let's say this should be called expected size. Expected size is bigger than initial capacity. Output buffer was not large enough. Try again. And then we do now the same thing. Output dot size and put begin. And then we say initial size plus this equals output size. I think this is correct. Oof. Huh. Yeah. So initial size we use here, initial capacity. begin. Begin is this, yeah. Begin. Output size, output, initial capacity, output size. Format, yeah. I think this is correct, but we need to test it. Let's add some comments here. So efficiently assign format to SCD like string. It is recommended to reserve a reasonable size. Well, let's say before we say that, can efficiently assign format to std like string. Can string can grow or can reallocate to acquire the required size. String, yeah, string can reallocate to acquire the required size to fit the formatted string. It is recommended to reserve a reasonable size for formatting. Efficiently append. And then here we say string cannot, string does not well, it will allocate here on resize. String max size. String does not. String is truncated if the formatted string exceeds the maximum size. The output string is truncated if the formatted string exceeds the maximum size. Okay. String the string will always well, let's say the output string will always fit the formatted string in its entirety. It's recommended to reserve a reasonable size before formatting, but it is not. Well, actually, it is not recommended. Like, if it is perfectly fine to pass like a default string with no, like with default capacity, right? Yeah, it is that. Yeah, I think this is fine. This is fine. I just hope that this calculation is really fast to calculate the required space. And then, yeah. But it will be the fastest if this one succeeds right from the get-go. So if you give a output string that already has sufficient capacity, then this will be the most efficient. If it has to grow, then there is a penalty, but this is not our most common use case, right? So I think we don't care much about this code path here. It can happen, but I would expect that the most common code path will be the first one, and this one is not expected to hit most of the time. Okay, we need to test if this works actually. It's quite a lot. Let's see if it compiles. So I probably will. Let's go to main function. Okay, let's put a stack string. Let's put a small basic string char. Let's put a, I don't know, 16. Yeah, and then we do assign format. Without the maximum, and then we do so let's say we give it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5. So that's 16, right? 17. Because of null terminator. Yeah, okay, but it's 16 characters. Okay, let's see. So this one should now succeed on the first assignment. All right, let's see. There we go. Okay, so so initial capacity is 16, yes. Then we resize it. And it says 16 size here. Okay, and then this one says size 16. And so we resize to 16. So our output contains data. What's that? 0, 1, 2, 3, 4, 5, 6. Capacity 34. Heap storage. Oh, it did allocate on the heap. Oof. Now that is unexpected. That is unexpected. I'm confused. Hold on, let's do it again. Where did it allocate? Like, what the hell? That's confusing. So here, right now, we have data. We don't have heap storage. We have the inline storage. Good. So initial capacity is 16. Now we resize. Let's step in here. What does it do? Count. If count is smaller than size, downsize, additive, upsize. Resize a string to contain count characters. This can lead to malformed UTF string. Count is bigger than size. What is size? The fuck is that? Oh shit. Let's okay, something is wrong here. Okay, so resize. Resize. So downsize. So let's see this. Code unit size. Size, code unit size, 0. Huh. Okay. Okay, so we go to upsize. Count 16. Count. Reserve. Allocate memory in the buffer for the extra chars. So this is 0 plus 16. Isn't it? Size of size. What the hell is that? Size of size. Okay, the debugger is going crazy here. Zero. Size representation span. What? Data end -1. To unsigned. There's nothing in there. New cap 16. That makes sense. Isn't this wrong here? New cap smaller than capacity. Shouldn't it be new cap smaller equal capacity return? To me, that looks wrong. Trivial case. New cap. So capacity, what does this return? Capacity, oh boy. Buffer. Minus null char size. Size it takes to store the null char. Of course, we would just write 1 in the code, but this gives us better semantics. Well, this is wrong, isn't it? Like this evaluates to 0. Should be size of this. Size it takes to store the null char. Of course, you would just write 1 in the code. But this gives us better semantics. Yeah, this looks wrong to me, doesn't it? Okay, but that aside, capacity minus null char size. Returns the number of code units the string has allocated space for. This assumes the 1 code unit per code point in the elements to come in terms of code points. What the? Returns a buffer size, which is different from the capacity for strings. The size is important to safely create string views that include the lookup table. Returns a buffer size. I'm confused. Size it takes to store the null char. Buffer. What is buffer? Char vector type. Small vector. So this capacity, it returns the wrong value here. Okay, so I think the fix here is to simply say size of this, which should now evaluate to 1. Let's test this. Can we see in debugger what this is? We cannot see it. Okay, but I think this will fix the problem. We got a Clang format error. Okay, but it did compile. Okay, let's test it again. So. Okay, so initial capacity. Ah, but now it shows 15. That doesn't seem right as well, doesn't it? Let's go back here. Let's jump in there. Capacity. 1. Okay, so now the null char size is 1. And this buffer is 17. Let's go in here. Capacity. Num inline elements 17. Minus this is 16. Look size in bytes. What the hell is that? Look size. Look size in bytes. Look size in bytes. One. So this somehow returns 15. So now we resize it to 15. So even though we have, even though it's 16 characters. Okay, but I think this will now succeed because yeah, I think this will succeed now. So the output now uses size, hold on, buffer data. So it uses the inline storage. And okay, I think this is correct now. So it gives us one less character than we thought it would. I don't know why that is. That's another problem we need to look at. Why? What is this? This thing here. How can we prevent this? Look size. Upper bound capacity. Strange. Can we maybe say, please treat this as an ASCII string? I really only need ASCII size code points. Aha. SUTF-8 string. Yeah, I don't... Okay, so it seems that it's always one of these. It can't be an ASCII string. Would be nice if it was possible. Let's search for ASCII if there are any matches. No, nothing. Huh. Okay, so it looks like it's not supporting ASCII, but it would be nice. Maybe they thought it's not necessary. Okay, well, it's not a big deal then. So we have one less capacity available. Yeah. Okay, but this fix certainly was correct. And now, so out 16, result dot size is 16. Huh. Right. So now the size is larger than the initial capacity. So it goes in here, which means it will now so it will have reallocated here data. Yeah, so heap storage now, capacity 34. And now thirty-four. 60. 60. There's quite a bit of mental gymnastics we need to do here. No. Okay, but now this should work, so it will return us output size 16, and this works. Yeah. Okay, so it has allocated here. I mean, no, here it has allocated. And then we have written the format in there. So now the output string should contain the whole sequence of characters. And it does, yeah. But it has allocated on the heap. Okay. Which is not optimal. So somehow 15. Wait, how long is this? 15. No. Oh, it's 16 long, isn't it? Hold on. 0 to 9 is 10. Oh, it's 16 long. Hold on. 0. Am I stupid? Okay, let's really make sure. It looks like it's 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 1, 2, 3, 4, 5, 6. Aha, it's 16 characters. Yeah, but there should have been enough, right? Because this one will be 17, so it's 16 excluding the null terminator. 16 excluding the null terminator. Okay, so basically now if we remove 1 here, now the character sequence will be 15 characters long, 16 with a null terminator. And this should fit on the first try, right? Let's see. So, so initial capacity is 15. And so we resize it to 15. And then we have the result here. And the size is 15. And so we output. And it's now resized to 15. And the buffer says data here, inline buffer 0 to 4. And this doesn't hit, and it's only 1 pass. Okay, so this works correctly. Let's also test the append. So if we then do here append format, let's do A, B, C, D, E, F. Yeah. Then this should now, yeah. So initial size should be 15. 15, yeah, 15. Initial capacity should be 15 as well. Yeah, 15. Then we resize to 15, which basically means it doesn't resize at all. Right, it just remains. Okay, then begin would be, yeah, 1 past the end, essentially. And then result will be, oof. So here we expect 21 size, right? 21. Yeah. Let's see. Oh no, 6. Ah, okay, 6. Yeah. Okay, and then 6 plus this is now 21. So expected size is 21. Yeah. And we resize now to 21, and we got a problem. Oh, well, no, that is interesting. That is very interesting, isn't it? Huh. The hell is that? Okay, somehow it requests a huge amount of bytes. Block size outrageously large. Where's it coming from? Man, did they never test their code? Count 21, resize. 21. Maybe I made a mistake, but so code unit increment 6, size should be 15, right? Buffer. It says 17. No, we are here. Hold on. 21 plus 1 plus expected lookup size. And expected lookup size is this outrageous number. The hell? Expected multi-byte size. New multi-byte entry cap. Why is this so big? Where's this value coming from? Here. Six. It must be here, is it? What is the size here? What is this? Code unit size. Oh boy. Oh. Okay, it's the null char thingy. Let's put a bookmark there so we remember that we've touched it here. Where do we put here? Bookmark. Okay, for some, so either it's a debugger tricking us, or we really get like an outrageous number here. New cap, expected multi-byte size, somehow outrageously large. What does size 4 do? Oh my gosh. It does some multiplications here. Allocate memory in the buffer for the extra chars. We have a 6 here, which is okay. But we have a CT size here. And it's not clear what this returns. Returns the number of code units in the string. Returns the number of code units in the string. Size 15, 15. Code unit size. I don't know what to say about this here. We pass it 21. 21. 21. Count. Upsize. Reserve. Size. $15. Okay, I still don't understand where this value is coming from. But it seems to crash because we give it like a huge value. And it's coming from somewhere. Right now, it's not clear to me where this comes from. Probably from this one, but where exactly? SCD max T. This one. Reserve. So it must be some of these. How about we put here, let's comment this code, and then we put ct.size, and we do what does it return? Size type. Size type, I think it was a const expr, right? Const expr size type ct size I put this here. Okay. Okay. And then we put a my God, what's up with the formatting here? It's outrageous. What does it take? New multi-byte entries cap. So we take const multi-byte entries cap, and we take these guys. We put that here, and boom, we pass it here. Good. We got some error, but who cares? Good. Let's stop debugging. Let's try again. Let's put a breakpoint here. Syntax error. Oh. What's... Okay. Cannot be const expr. Fine. Clang format is atrocious software. Absolutely atrocious. Good. So this one gives 0. This one gives 0. Okay. So on the first call, it works. Now the second call, let's see what this does. So we have this. Well, maybe we make a mistake somewhere and overwrite something. That could also be. Okay, so we have initial size 15. Initial capacity begin. Oh. Oh, I think we do a mistake here. Because here we are writing over the bounds of the buffer. Yeah. Yeah, that's stupid. We need to put initial capacity minus initial size. There we go. Well, is this also wrong here? Max size. It's also wrong here, isn't it? Max size minus initial size. Okay. Okay, let's try this again. Okay, so okay, so let's step in here. All right, so initial size is 15. Initial capacity 15. So this one will do nothing. Here we have initial size. Okay, so we had at the end, and we format now to 0 essentially, right? That's 0. So result will give us 6 out. Is that okay? Expected size is now 21, and now we resize to 21. So that will be 21, yeah, and we will have heap storage with 34, and now we go in here and we put output dot size, which is 21. I hope. And that should put us, let's see, base, no, out, base, wait, what? Oh, 6. 6. So now initial plus this equals this. So yeah, this should pass. Let's look at the output. The output says data, heap storage. Huh. That doesn't look right, does it? That looks wrong. Oh. Yeah. Yeah, that's wrong. So initial capacity 15 minus that. Yeah. And here format to n. Begin. You also need to deduct initial size. Yeah. Initial size. So output dot size minus initial size begin. Oh, but now this one is wrong because we reallocated here. This one is outdated now. Haha. Type name begin. So we need to let's put this guy here like this, and let's remove this, and here begin, format to end, begin. I think this is okay because here we don't grow. Oof. Oh, that makes it hard to read. How about I put here begin? Then we update begin here. Initial capacity. Let's make a comment. May reallocate. May reallocate. here as well, may allocate or reallocates, yeah. And here as well, may reallocate. This one doesn't allocate. No reallocates. No reallocates. Does not reallocate. Okay, and here's the other way around. Does not allocate, does not allocate, may reallocate. So initial capacity minus initial size. Maybe we should also cache this guy, consts. Or maybe not. I think we should put this. So if you put it here, oh, it's okay. Let's put it there. Okay, so it's begin plus size, yeah. Initial capacity minus initial size, yeah. Format, okay, and here it's again output begin plus this, and then output size, which is now this one here, minus initial size, yeah. I think this is correct. Does not reallocate, may reallocate, does not reallocate, may reallocate. And it's the other way around, may reallocate, does not reallocate. Yeah. Okay, I think this is correct now. Let's see. It's quite complicated. Good. All right, so now, ta-da, ta-da. Okay, so, ta-da. So expected size is 21. Now it reallocates here. And our expected size is bigger than the initial capacity. Output buffer was not large enough. Try again. And now this has succeeded. Let's take a look at our output buffer, and this one looks good now. Yeah, good. Capacity 34, and the size should be 21. Size is, ooh. Did we corrupt it again? Why is the size here so huge? Is that already on the starts? Let me see. Let's go to main function. Let's put a breakpoint here. str buffer size 17. Okay, let's do a size t size equals str dot size. Oh, what happened there? So str size is 21. Okay. Okay, I mean, the size here looks really gigantic. I wonder at which step does it happen. Okay, so the size here is okay. Then we go one forward, and now the size is still okay, 17. Okay, let's go in here. Size is still okay. Now it will allocate. Expected size 21. And now the size is somehow super huge. I don't know why. Let's search for size underscore. Size. Here. Internal size type. Internal size type. I'm confused. Output. So this size looks good, but this size, buffer. Ah, buffer. Let's look for the buffer. My gosh. Buffer. Okay, so here's a buffer. Let's look into the buffer. Ah, could it be that since we no longer use a buffer, then maybe it just like purges it or sets to like some outrageous size. Maybe that's why. Like an invalid size. Yeah, it's probably an invalid size. Yeah. Let's go here. Copy expression, copy value. Let's put it into the calculator. Programmer. Oof. Well, looks like this number is too large, yeah. Okay, let's go to programmer. And let's just type it. So it's 922337. Oops. 7203. Wait, why don't we just show it in hex? However, much simpler. Hexadecimal. Aha. 822. Ah, they probably put a flag on this one. They put a flag, 8. And if this flag is set, then it's invalidated or something like this. That's my suspicion here. Okay, and then we don't care. That's probably fine. Yeah, good. This seems to work then. Seems to work. Yeah. Good. Well, that was quite a journey, but hopefully that is a fast and efficient string building now. I mean, it's all in the stack. We use the FMT format. In the best case, it's just one single call. There's no allocation here. Does not. Maybe we should call. Maybe we should say does not. Does not allocate. May allocate if required size is larger than output string. The output string capacity. Okay, then we say here does not allocate. May allocate. Does not allocate. May allocate. Okay, may allocate of required size is larger than output string capacity. But hold on, isn't this wrong here? Resize, initial size plus max capacity. That's wrong, isn't it? Yeah, it's wrong. Wait, max size, append format. Append format. I think here we should just say max format, max size, resize max size. Max size. Initial size should be const. Okay, so we resize to max size, and then here we deduct initial size. Begin max size, initial size. And the written is, well, it's questionable. Like maybe it should be max size plus initial size. The output string is truncated if the formatted string, if the appended formatted string exceeds the maximum size. Now, if the entire string exceeds the maximum size, the output string is truncated if the format string and the formatted string and the appended exceeds the maximum. If the previous string plus the appended formatted string exceeds the maximum size, the output string is truncated if the previous string plus the appended formatted string exceeds the maximum size. I think that is fair. Yeah. I think that is fair. Max size. Yeah. Okay. So we resize here. Max size minus initial size. Yeah. Okay. I think that's good. This should not be try again. It should be output buffer was not large enough. Repeat. Because it's not a try, but this is expected to succeed. Repeat. Repeats on the resized string. Yeah. Okay. Well, it was quite a bit of work. Yeah. Okay, good. Let's test it one more time. All right. So str. That looks good. Buffer is inline storage, and now we append, and it's now on the heap, and it's all there, and the size is 21, and that matches the 15 plus 6, 21. Yeah. Okay, this looks correct to me. Good. Then let's remove this and remove that. Let's open an issue report in that repository so that they can fix what it was small, right? Small issues. Well, the question is, do they still work on this? Maybe not. Bug report. Always these stupid templates here. Null char Nightjar size has wrong size. Um, um, is should be CPP. Nightjar size has the wrong size. Good. And that's it. Good. I wonder if we should so we made a fork of this thing. Small. Let's take this guy, copy. Let's clone this. Destination. Projects. Let's put it here in the code small. On that note, maybe we should also move the imgui branch. Can we move it here? Oof. That's a good question. Can we move it I don't know. maybe let's close it. Then we go to projects. Then we take imgui. What is this here, by the way? Let's see. Then we take imgui and we put it in here. Then we launch Git extensions. Then we click here. Okay, and then we do open repository. We do imgui here, open, and there we go. Okay, so we have relocated it manually. Okay, how do we go back here? Yeah. Okay, so how about we create a new branch? Create branch. Fix. Fixing. Let's say local fixes. Yeah. Because to me it's unclear if this will be fixed anytime soon on this branch, because it looks to be quite inactive, right? Okay, so local fixes. Then we go to small, include small string. Then we go to null char size here. There we go. Then we put here size off. There we go. And then we push it. Now we commit it. Fix null char size. Stage commit. All right, then we push it to remote. Push. All right, and then we go to unassemblize and we put CMake lists. And we put here this origin local fixes, and hopefully that will work. Let's see. So basically we now hope that the assembly armada unassemblize third party small include small, and we look for string and we look for null char, and now it's fixed. Yeah, okay, good. So we use a local version for it for now, where we have this fix. It's not a huge fix, but certainly the null char size should not be 0. Good. Anything else? No, I think we are now prepared. So So we have yeah, we have a new string now, and a new oh, I just realized this one here should be 1024 minus 1. Well, that's not quite right, is it? Common types 1024 minus 1. There we go. Yeah. Let's call it null character. Null for terminating null. Okay. Good. Yeah, let's take a break here. I think we did some good progress. Then next session we will use the stack string at more places to get rid of std string allocations, and then we can finalize this change and merge it, and then we can go to the next thing. Good. Yeah, that's it. I wish you a great day or night until next time. Goodbye.